Welcome back to PowMr's channel. In this video, we will introduce the possible codes and solution for error codes in the Keeper and POW-M series controllers. First, let's focus on the Keeper series. The error codes in the Keeper series consist of 3 characters. The first character E stands for error, the second character indicates the number of existing faults, and the third character represents the specific fault code. I will explain each fault code one by one. Error 1 indicates the battery over discharge, which primarily affect the lead-acid batteries, as lithium batteries typically have a built-in BMS for automatic protection. When the voltage of lead-acid battery drops below the under-voltage cutoff voltage of 10.8 volt, the controller will display this fault code and stop discharging. To resolve this error, charging the battery until its voltage exceeds the under-voltage recovery voltage of 12.6 volt, the controller will then clear the error and resume normal operation. Error 2 indicates the battery over voltage. When a lead-acid battery's voltage exceeds 16 volt or 32 volt, depending on the system voltage, the controller will display its fault code. Disconnect the PV input and stop charging. After the error occurs, measure the battery voltage and inspect the battery's appearance to confirm if there is any damage. Check if the battery temperature is too high. If the temperature is too high, let it cool naturally. Then use an appropriate load to discharge the battery safely until the voltage drops below the 16 volt or 32 volt. The controller will resume normal operation once the voltage is within an acceptable range. Error 3 indicates the controller overload. This error occurs when the load exceeds the maximum capacity supported by the system. The maximum load capacity of the controller is determined by multiplying the battery voltage by the maximum discharge current of the load terminal. For instance, the Keeper 1240 has a maximum discharge current of 30 ampere, and when connected to a 24-volt battery, it can support up to 720 watts. If the load exceeds this capacity, the controller will display an overload error. To resolve this, reduce the load to ensure the controller operates within its supported range. Error 4 indicates that the load side components of the controller are damaged. This fault may be caused by a short circuit at the load end or by connecting an inverter to the load terminals of the controller. Connecting high-power loads or an inverter can cause excessive current, damaging the internal components of the controller and resulting in irreversible damage. Therefore, it is crucial to connect the loads according to the controller's load capacity. If an inverter needs to be connected, please connect the inverter directly to positive and negative terminals of the battery and avoid connecting it to the controller's load output terminals. Error 5 indicates controller over temperature. When the controller's temperature exceeds 88 degrees Celsius, this error will appear, and the charging will stop. Ensure that ambient temperature around the controller is not too high, and provide adequate ventilation. Once the temperature drops below 73 degrees Celsius, the inverter will restart and resume normal operation. To prevent over-temperature issues, install the controller in a location that avoids direct sunlight and has sufficient ventilation space around it. Error 6 indicates PV input over voltage. Ensure the PV array's power configuration respects the controller's maximum PV array open circuit voltage. If the voltage exceeds the limit, reduce the number of PV modules or change the series power load configuration to ensure normal system operation. Next, let's discuss the fault codes for the POW-M series controllers, which are composed of 2 digits. Volt 18 indicates low PV input voltage. The PV input voltage should be higher than the boost charging voltage of the connected battery plus 2 volts. For example, if you are using the POW-M25 Pro to charge the full DC battery, the PV array voltage should exceed the 14.6 volt plus 2 volt. Volt 60 indicates high controller temperature. When the controller temperature exceeds 80 degrees Celsius, it will automatically stop charging and discharging. The controller will resume normal operation once temperature drops below the 75 degrees Celsius. Volt 63 indicates battery overvoltage. When the battery voltage exceeds the boost charging voltage, the controller will stop charging. Measure the battery voltage and inspect the battery's casing for damage. Ensure the battery is safe, and if the temperature is too high, let it cool naturally. Then discharge the battery using the appropriate load until the voltage drops below the boost charging voltage. The controller will resume normal operation once the voltage is within an acceptable range. Volt 65 indicates low battery voltage. Charge the battery to resolve the error. Once the battery voltage recovers to the MPPT tracking return voltage, the controller will clear the full code. Volt 71 indicates PV input overvoltage. The PV input voltage must strictly adhere to the maximum open circuit voltage specified in the manual. Exceeding this voltage may damage the controller's PV circuit board, preventing it from charging the battery using solar energy. Ensure the PV array voltage does not exceed the controller's maximum open circuit voltage. Reduce the number of PV modules or change the serial power configuration to lower the PV array voltage. Volt 73 indicates overcharging current. Since the charging current depends on the PV array configuration, reduce the number of PV modules to lower the charging current. Volt 72 indicates excessive discharge current at low terminal, exceeding the maximum hour current limit. This may be caused by multiple high current loads. Reduce number of loads to lower the discharge current and clear the error codes. That's all for the error codes and the solution for the Keeper and POW-M series solar controllers. Thank you for watching and see you in the next video.